Hi, so this is just a basic overview of trigonometry and basic rules of it. At this point, we will be using a coordinate plane to help graph angles and express the ideas, as well as later graphing trig functions. The little O with a hat represents an angle. It's called a theta. Basically, theta is going to be how far around the circle we went. R is the hypotenuse of our right triangle that will form, and it's also the radius of the circle we're going around. To create a right triangle that we can use our trig functions on, a vertical line will be drawn connecting the radius to the x-axis. With the theta set at the origin, the x-axis will then become the adjacent side, and the y-axis the opposite side. Using a coordinate graph allows us to use angles that are ranging from 0 to 90 degrees. So now that we know the basics of why we are doing this and what we are doing, let's get down into the different types of trig functions. One of the first trig functions is called sine. Sine is opposite over hypothesis. In this case, it'd be y over r. Cosine is adjacent over hypothesis, or x over r, and tangent is opposite over adjacent, or y over x. Typically, an angle increases as you go counterclockwise. However, a negative theta demonstrates that you're going to head clockwise. Sine of negative theta equals negative sine of theta because the y is going to change depending on whether you go clockwise or counterclockwise. Cosine of negative theta is equal to cosine theta because the x value will remain constant. Tangent of negative theta and cotangent of negative theta will both become negative because of the quotient of a positive and a negative. Another nifty trick for these right triangles is that cosine of A will equal sine of B and sine of A equal cosine B, tangent A equals cotangent B, and tan of B equals cotangent A, as long as A plus B equals 90. This is due to the fact that the ratio will remain the same even though the angles are different. So after all those new ideas, now is when we start applying math to them. There are 6 main trig identities in the basics. The first one is that tangent will equal sine of theta over cosine of theta. The second one is that cotangent of theta equals cosine of theta over sine of theta. Both of these are obvious based on the definition of tangent and cotangent. The next one is that tangent times cotangent will equal 1. That again is apparent because they are multiplicative inverses. The fourth one is that sine squared plus cosine squared equals 1. This is due to the Pythagorean theorem being used. The fifth theorem is that tangent squared plus 1 will equal secant squared. This is due to the definition of tangent being sine over cosine, and then 1 being made to have a common base. 6 is that cotangent squared plus 1 will equal cosecant squared. This is the same idea, however, it's just with sine being the common base. Now, to make your life easier, trigonometry has some special angles and special rules that you should learn in order to apply them later on in other formulas. We have two special types of triangles, a 30-60-90 triangle and a 45-45-90 triangle. We also have a coordinate plane, which is useful for figuring out the values of cosine, sine, tangent, and cotangent at 0, 90, 180, 270, and 360 degrees. All of the values that I'm placing down on this table are found from using the ratios of the special triangles or by using the coordinate plane. The coordinate plane is helpful because it'll tell you what the x value is, the cosine, or what the sine value is, the y. Tangent and cotangents will have dashes where the answer does not exist because the denominator would be 0 based on the ratio they have. I recommend that you memorize these or at least learn them because these will be used in most formulas. We're going to begin with sum and difference identities. These are the identities that relate to angles that are the sum or difference of two known angles. We're going to begin with sine. Sine of A plus B equals sine of A times cosine of B plus cosine of A times sine of B. And sine of A minus B equals sine of A cosine of B minus sine of B cosine of A. One way to remember it is that what's your sine is a pickup line, and that in a relationship, opposites usually attract, much like the sine and cosine and the A and B. Also, in this case, the sine of the sine stays constant. Here's an example. You can pause the video and try to work it out on your own. As you go along, you can check your work along with mine to make sure that you have been doing it the correct way and that you get the correct answer. Next is the sum and difference identity of cosine. Cosine A plus B equals cosine A times cosine B minus sine of A sine of B, and cosine A minus B equals cosine A times cosine B plus sine of A sine of B. One way to remember these ones is to think of the cosines as cousins, and that the cousins who are the most similar tend to stick together, much like the cosines and the sines stuck together. Also, since cosine was in the name, cosine gets to go first. In this case, the sign is changed just 'cause. So again, here's another example. You can pause and try to work it out on your own, or you can just check your answers as you go along. The reason I write the answer as if there are two results is because it depends on whether or not you've rationalized your roots. And I tend to rationalize mine. Now is tangent. Tangent of A plus B equals tangent of A plus B over 1 minus tangent of A times tangent of B, and tangent of A minus B equals tangent of A minus tangent of B over 1 plus tangent of A tangent of B. One way to remember this is the tangent angels and the dangent demons. The numerator of these equations is very straightforward and it matches almost directly with what it was exposed. However, in the denominator, there are demons, such as the fact that it's 1 minus if you're adding A plus B, and 1 plus if you're subtracting A minus B. And then also that this trouble is multiplying greatly. Here are some examples that you can do for tangent. Again, you can pause the video or you can work along with me as we go. In this problem, I did not take the time to rationalize the root. The second example is rather tricky in that it uses cotangent rather than tangent. The formula to find the sum and difference of a cotangent is just the multiplicative inverse of that of tangent. In this step, we just multiply both the numerator and the denominator by the square root of 3 so as to get rid of the pesky square root of 3's in the denominators. Also, now we multiply them and we FOIL in order to make it so there are no loose square roots in the denominator. Double angle identities refer to when you're trying to find the trig function values of an angle double the size of the one you were given. Sine of 2a equals 2 sine of a cosine. One way to remember this is that sine is again a flirt, and you don't want to date the same person as yourself, and two people are more fun than being alone. This can be remembered by the opposite of the functions cosine squared plus sine squared equals 1. In this case, the negativity of the sine squared has caused them to become two different people, as in the cosine 2a. Tangent of 2a equals 2 tangent of a over 1 minus tangent squared a. Again, the top part is rather straightforward and makes sense, yet the denominator has that pesky 1 minus tangent squared a, which makes sense because it's multiplying the trouble. Here's an example problem that'll use all of these double angle identities, so you can try this on your own or again watch me do it step by step. Half angle identities are what you will use when you know angle A, but you want to know what half of that would be. the formula for half of a for sine is plus or minus the square root of 1 minus cosine of a over 2. A way to remember this is you're going to do 1 minus cosine squared to find sine squared, and the square root of sine squared is sine, and then you divide it by 2 to get the half angle. Cosine of a over 2 is going to be plus or minus the square root of 1 plus cosine of a over 2. It's 1 plus cosine of a to make it larger, and then you divide it by 2, because it's kind of like averaging, but kind of not. And then tan of a over 2 equals plus or minus sine of a over 1 plus cosine of a. Basically, we're doing what tangent equals sine over cosine, but we're altering it so it's that half angle. Here's an example for you to try so you can see if you understand what's going on. Now we're going to do sum to product identities, which is when you have two trig functions added together and they have a multiplicative identity. For example, like sine of a plus sine of b equals 2 sine of a plus b over 2 times cosine of a minus b over 2. So I'm just going to write them all out now, and then we'll go back and I'll give you cool ways to remember them once they're all written out. In the case of the sine A plus sine B sum to product identities, there's going to be both a sine and a cosine multiplied by 2. And in both cases, you're going to either add both the angles together or subtract both the angles and then divide those by 2. The way you know which one's going to be sine of A plus B or cosine of A plus B is look at the sign if it's plus or if the trig functions are being added or subtracted. For cosine sum to product identities, you're either going to have both cosines or both sines. If the trig functions of cosine are being added, it's going to be times 2 positive and cosine. If they're being subtracted, it's negative 2 and then use sine. Tangent is straightforward with sine of a plus b on the numerator and then cosine of a times cosine of b in the denominator, because again, multiplication happens in the denominator. Here's another example for you to try on your own. You can either pause the video now and try it, or you can just watch along. Now we are going to do product to sum identities, which is when you have two trig functions being multiplied by each other that give a sum identity. The three you need to learn are the sine of a times sine of b, cosine of a times cosine of b, and sine of a times cosine of b. That one can be reversed because of the commutative property. All of these are going to be multiplied by 1/2. In the two sine of a times sine of b and cosine of a times cosine of b, cosine is the one being used. So think of cosine as a square because that's what both of those are. In the case of sine of a times cosine of b, we use sine. To remember the order of operations in the sine of a times sine of b, you can think that sin is bad and bad, but it can be fun in the end. So it's going to be cosine of a minus b minus cosine of a plus b. To remember cosine of a times cosine of b, you can think that cousins are fun, but they can sometimes be annoying. So it's going to be cosine of a plus b plus cosine of a minus b. For the sine of a times cosine of b, you use sine instead of cosine, but then in that case you follow cosine's pattern of positive, positive, negative. So here's another example for you to try. Now we're going to talk about how you would graph all of these trig functions. Sine of x is a wave that passes through the origin. It has an amplitude of 1. Cosine of x is a wave as well, but this one passes through the points 0, 1. Unlike sine and cosine, tangent is not a wave and it's more of a curved line. It has asymptotes at 90 plus 180k to the points where x would equal 0. Now that we've got the basic sum, we're going to do the multiplicative inverses graphs. Secant, which is 1 over cosine of x, will look similar to cosine, except that all of the values will be flipped over that 1 and negative 1 amplitude. Same with cosecant of x, which is 1 over sine of x. It's like sine of x, except flipped over those two lines. Cotangent of x is similar to tangent of x, except that it travels the opposite way of the tangent lines, and it also has its asymptotes at 180k rather than 90 plus 180k. Formulas for these trig functions are usually written in the form of a f of x plus c. A is the amplitude and it represents vertical stretch. It's going to say how much above and how much below the center line the formula is going to reach. C is the vertical shift. A positive vertical shift is going to lift it up, and a negative vertical shift is going to shift that center line down. The f of x part can vary too. This is what's going to be inside that trig function. So it can be trig function of h of x plus k. Similar to a, h is the horizontal stretch. It'll say how much longer or shorter the trig function is going to be. K is going to shift it left or right. Trig functions are periodic, which means that horizontal stretch will affect the length of the period. Sine of x has a period typically of 360 degrees. Cosine of x has a period of 360 degrees, and tangent of x equals 180 degrees. A period is how far it will go before it repeats again. To find the period of a new function, you divide the normal one divided by h. So now that we've got these basic trig functions, now we're going to do the inverse trig functions. Just like a function has an inverse, so do these ones. While sine of x takes an angle and finds the ratio, arcsine will take the ratio and find the angle. Arcsine will have a domain of negative 1 to 1, as that is the range of sine of x, and a range of negative 90 to 90, because that is where that domain can be shown. Tangent will have a domain of all numbers, however, its range will be negative 90 to 90. Cotangent will also have a domain of all real numbers and a range of 0 to 180 like cosine. These inverse trig functions are useful because they'll allow you to find an angle from a ratio and to find another ratio from that angle. One of the last things you need to know is how radians work. Radians are a way of measuring circles in terms of pi. 360 degrees equals 2 pi. To translate from degrees to radians, you multiply by pi over 180. To get from radians to degrees, you do 180 degrees over pi. Here's a listed table that you should probably know the radians of from memory, or you can solve them as you go. The very last thing I'm going to show you is these different trig things that we can do. We can find the area by multiplying 1/2 times side B times side C times angle A, which is going to be basically the two angles adjacent to A multiplied by the angle in between them. There is also the law of sines and the law of cosines, but I didn't feel like going over that in this video, so you can look at that later on your own. So basically, that's the quickest summary I could give in 20 minutes of a whole semester of trig.